Hey everybody, I wanted to start out by creating a video just to introduce ANOVA. So that's what you've been working on this week. I've uploaded all the PowerPoints for the rest of the semester. Chapter 10 has to do with the first ANOVA that we're talking about with the one ANOVA. So the first few slides really talk about t-tests and always kind of start out with what we've done in the past. So compare to what we're doing right now. So a few of the tests that we've covered so far is the one sample t that was comparing population to a sample, right? So your two means. And then we looked at an independent test. This time we were looking at two sample means, comparing them. When those sample means are independent of one another, and then the paired t-test. Again, two sample means different, those means were related. And mathematically we have to do differently because when you have different, that are related, the variability is different. You have greater statistical power and you have to control for that, to take that into consideration. So anyway, that's why we have different tools for different types of designs, right? So the thing all those tests have in common is that we're comparing two mean population to a sample or two samples. So a lot of research designs are not looking at simply whether there are whether two groups differ. When you read journal articles, you often find that you have an independent variable then related, so you have more than two treatment conditions. You might have a control group, you might have an experimental group, and another experimental group. So you have three or how many different treatment conditions. And the notion of a t-test is that you can only compare two means at one time. So what do? So the question, well, the answer, I guess, would be let's just hold of t-tests, right? That means super easy. And unfortunately, people do this in practice. The problem is that every time you do a t-test, you have the risk of committing a type 1 error depending on what you set that alpha at. Okay, so remember what alpha level is. I typically set it at 0.05 or 0.01, and it translates to either a 5% or 1% risk of that type 1 error. Essentially saying there is a difference between your groups when in fact really is not. So if you were to repeat the study 100 times and 5 times out of 100, you might find that there's a difference between your means, and there really truly is not at all. So every time you do a t-test, you have this 5% risk, this 1% risk. So if you have, let's say, 3 means that you're comparing, you have to compare mean 1 versus mean 2. That's a 5% risk. Then mean 1, 3, there's another 5% risk. And then mean 2 and 3, and that's another 5% risk, so 15. You now have a 15% chance of committing type 1 error. So think about how to be significantly enhanced with the additional group that you add on. So the reason we can't do a number of t-tests. So for that reason, Fisher came up with an ANOVA. And what an ANOVA does is enable you to compare an unlimited number of means. You could do, usually we do 3 or more in one swoop. So ANOVA does that, controls your type 1 error, so you can set your alpha level 0.05 or 0.01. You can compare a number of means at the same time, and you can certainly you haven't rejected the null with an unreasonable amount of type 1 error. So that's why we do ANOVA. So a one-way ANOVA simply, if we were to define it, is a test in which we have a single independent variable that's manipulated so that there are 3 or more levels or more treatment conditions. and we're measuring a single dependent variable. And what we're trying to do is determine whether those groups differ. So that's I'll be posting some additional videos to talk about specifics of the ANOVA, but conceptually, that's what we're doing. So hopefully that makes a little bit of sense. As always, you can reach me, email asikorsky@tamet.edu. I hope you guys have a great day. Take care.